Hi everyone, welcome to my channel, and in this video we are going to discuss a problem known as median of two sorted arrays. This problem is of Leetcode, and in this problem we are given two arrays nums1 and nums2 which have size m and n respectively, and we have to return the median of these two sorted arrays. These two arrays are sorted, which is it is given from beginning only. Now to solve the problem, let's us proceed how we should solve the problem. Let's say our first array is 1, 2 and our second array is 3, 4. Now to find the median of these two arrays, we should first combine them or merge them into a newer sorted array C, which would have a size of the sum of the sizes of A and B. And this array would also be sorted, and the elements of C should belong to A and B only. And both the elements of A and B should occur in C once. It is compulsory. So the array after these conditions would be 1, 2, 3, 4 after merging A and B. Let's take one more good test case for it. Let's say our first array is 2, 6, 9 and second array is 3, 4, 5, 7. So after merging these two arrays, C should look like 2, 3. Let me just draw 3 properly. 2, 3, 4, 5, 6, 7, 9. This is how C should look like, and the size of C here is 7, and the size of A and B are 3 and 4 respectively. Now once we are done with that, now let's come to how we should find the median of A and B. So to find the median of A and B, we should actually find the median of C only, because C is the combination of A and B only. So how you would find the median of C? To find the median of C, we should first know how to find the median of an array. To find the median of an array, there are two cases. First, when the size of array is odd. When the size of array is odd, let's say our array for which we have to find the median is 1, 2, 3, 4, 5. So indices for the arrays, this array is 0, 1, 2, 3, 4. So the median of this array is actually the middle element of this array only. And an odd sized array always has one middle element, and that can be accessed by going to the index a of a dot length by 2, where a dot length is the length of the array. So that becomes a of 5 by 2, that is equals to a of 2. Because why we are getting 2 here? Because 5 by 2 gets rounded to 2, because 5 is taken as an int. So a of 2 becomes 3. Now the case when the size of array is even. When the size of array is even, let's say our array is 1, 2, 3, 4, 5, 6. In this case, whenever an array is even size, it does not have only one middle element. In fact, it has two middle elements, and in this case they are 3 and 4 respectively. How we should access these two middle elements? We can easily access them by a of mid minus 1 index and a of mid, where mid is equals to length of a by 2. Mid is equals to length of a by 2. That makes a of mid minus 1 is equals to a of 6 by 2 minus 1. That is equals to a of 3 minus 1. That becomes a of 2. Here the indices are 0, 1, 2, 3, 4, 5. So that makes it 2. Sorry, 3. Now for a of mid, we would just simply do a of 6 by 2, that's equals to a of 3, that becomes 4. Now to find the median of an even sized array, we cannot just say that 3 is the median or 4 is the median of this array. To find the median, we have to take the average of both the middle elements that we are getting, both the middle elements. That becomes median is equals to 3 plus 4 by 2, that is equals to 7 by 2, that is equals to 3.5. So the median here is 3.5. Let's again record. For an odd size array, the median is just exactly the middle element, that is 3. This is the median. For an even sized array, we have two middle elements and we take their average, and by taking their average we get the median. Now once we are clear with how to find the median of an odd sized array and even sized array, we can move forward to how we should merge two arrays, because if we don't know how to merge two arrays in our code, then how you would actually find the median. So let's see how you should merge two arrays. Let's say our first array is 10, 9, 8, 7, 6. I know it's unsorted. Let's say take a sorted array 6, 7, 8, 9, 10. And the second array is 5, 11, 8, 8, 4. Let's take the sorted version of it. 4, 5, 8, 8, 11. Now to merge this array and this array into a newer array C, which has a size of A plus B, we should have a procedure like this. Let's just write them down here separately. 6, 7, 8, 9 and 10. This is the first sorted array B, A, and the second sorted array is 4, 5, 8, 8, 11. This is the second sorted array B. A is this, B and B is this. So this is clear. So now you would keep an ith index starting from the first element of A and jth index starting from the first element of B. Now we should compare I and j repeatedly, but with some conditions. When we compare I and j, the first element of both the sorted arrays, if the element at one sorted array is smaller than the other sorted array, we keep the element in our newly sorted array C and move the index of the element which is next to the element that we have stored. And that is, if let's say we compare 6 and 4. So 4 is smaller than 6, so we would keep it in the newer array C and we would move the index from 4 to 5. Now we would be comparing 5 and 6. Now we would compare 5 and 6. 5 is again smaller than 6, so we would store 5 and move the index of j to 8. Now 8 and 6 are compared. Now 6 is smaller than 8, so we would store 6 and move the index of I to 7. Now 7 is compared with 8. Now 7 is also smaller than 8, so we would store 7 and move the index of I to 8. Now when we encounter two equal elements, we would just store one of them and move the index to the next of them, because that wouldn't affect our newer sorted arrays C formation. C would be formed same only either we move j or either we move I when two elements are equal. Now let's say we stored 8 and move our index to the next state of B. Now 8 and 8 are again compared, both of them are equal. Let's say we just moved I now. We can move J also, that's not a problem. And now we stored 8 again. Now 8 and 9 are getting compared. 8 and 9 are getting compared now. So now 8 is smaller than 9, so we store 8 again. And now J comes to 11. 9 is smaller than 11, so we store 9 and move I's index to 10. So now 10 is smaller than 11, so now we store 10 and move I's index to. Now there is no element to point to, so I has ended. So once whenever any index whether I or J crosses the length of their respective arrays, we should end the loop. We should store no more element in C and we should end the loop. I know one element is still left for us to store 11. For that we would use a loop to complete the array which is left incomplete. I mean here J hasn't crossed the array yet, so we will store a loop. We would use a loop to store J in C. Until J crosses the array, we would use a loop to make J cross the array and store 11. Now let's take one more test case to make things even more clear. Let's say I take this test case. I take this test case here, and I will take one of them only. That is our array A, let's say, is 2, 4, 7, 2, 4, 5, 7, 5, 7, 8. Yeah, is it right? Yeah, 2, 4, 5, 5, 7, 8. Now the second array would be 2, 6, 6, 7, 10, 10. Now we would proceed like this only. For C, we would keep an I at A's first element and J at B's first element. We would compare both of them. Now both of them are equal, so we can store any one of them. Let's say we store the 2 of A and move I's index to 4. Now 4 and 2 are getting compared, so 2 is smaller than 4, so we store 2 and move J's index to 6. Now 4 and 6 are getting compared, so 4 is smaller, so we store 4 and move our index from 4 to 5. Now 5 is smaller than 6, so we store 5 and we move our index to the next 5. Now 5 is again smaller than 6, so we store 5 and move our index to 7. Now 7 is greater than 6, so we store 6 and move J's index to the next 6. Now 6 is again smaller than 7, so we move our index to 7 and store this 6 first. First we store this 6 and then move our index to 7. Now 7 and 7 are equal, so we can store any of them and move forward. So we store, let's say, the J is 7, the second array is 7 first, and move our J index to 10. Now 7 and 10 are getting compared. 7 is smaller than 10, so we would store 7 and move our I to 8. Now 8 is smaller than 10, so we store 8 and we come out of the loop. Now you see, whenever we are coming out of the loop, whenever any one of either I traverses the length of its array or j traverses the length of its array, one of the arrays would remain uncrossed. That means some elements would be left out and they are still not placed in C. C is still empty and it has not covered all the elements. One of the array would still have uncovered elements. So to cover those elements, to have those elements in C again, you would run a loop until j, or until either j or until either I gets filled up, or until either I or j traverses their array completely. So we would make j traverse its array completely from the point it has been left out and store the element in their order. Let's say j was at 10, so we would move forward j to the next 10. We would first store I should show you again. This was not there, 10 was not there, and j was there. So first we should store 10 from the point j was there, and we would move j to the next 10, and then we would store this 10 also. Then we would make j come out of the array. We would make j traverse the whole array and come out of it, and that's how we will cover the all the both the arrays and make our C full. I hope this made it clear for you how you should store and the elements of A and B into C, or how you should merge two sorted arrays. This technique of keeping index I and j upon the first elements of A and B and then comparing them and traversing over the arrays is called two-pointer technique, and we would see the code of also it, how we would proceed to do it. Now once we have found the merged array, now finding the median of it is pretty simple, because we can just see if the size of this array is odd or even. Here it is even, so the middle elements would be 12 by 2, a of 12 by 2 and a of 12 by 2 minus 1, that is equals to a of 6 and a of 5, that is equals to 6 and 6 are the middle elements of this array. So the median would be 6 plus 6 by 2, that is equals to 6 only. So 6 is the median. So 6 is the median of the array. That's how we would find the median of the array. Let's proceed to write the code for it. Now we have this template for our code. Let's just copy it first, because we have to submit it like that only, and take it here. Now we have two arrays, nums1 and nums2. What we had said that we would make another array, nums, and it would have a size of the sum of the length of nums1 plus sum of the length of nums2. Now once we are clear with this, now we would keep an int I equals to 0. That would help us to traverse for nums1, and j equals to 0. That would help us to traverse for nums2, and int k equals to 0. That would help us to store elements in num. And once whenever we store element in nums, we would increment k so that nums could store the next element for its array. So you would run a while loop for a task while I is less than nums1 dot length, and j is less than nums 2 dot length. Why we have placed an and condition? Because whenever anytime one of them crosses their respective array's lengths, then they should come out, the loop should end. It should end, and we should proceed to the further task, that is filling the incomplete elements. Now let's proceed to how we will write the code for comparison. Let's say nums1 of I is less than nums2 of j. Let's say we compared the first element, and nums1 element comes out to be lesser than nums2's element. Then we would just store nums k with nums1 element, increment the I as we have stored nums1 I. As we have told, whatever we store, we increment the index from that to the next element, and we would increment k also, so that we can store the next element in nums. Now we would come to an else, and an else would denote that nums2's element is either less than or equal to nums1's element. So we would store nums2's element in nums k. So nums k is equals to nums2's j, and we would increment j, because when we store nums2, we should move the index to the next element of nums2's element that we have stored, and we would increment k also, so as we have to store the next element of k of nums2. So once we are done with this, once this loop ends, either a or b would be left uncovered. One of them would end, and either I or j would not have completely traversed their arrays. So to check for which one has not completely traversed their arrays, we would keep a condition: if I is less than a dot length, if I is less than nums1 dot length, we would simply we would keep a while loop for also that until I covers its array. We would store its elements into nums. That is, we would store the nums1's elements into nums until I covers nums1 completely. And we would also make the same check for nums2 as well with j. If j has not covered nums2 completely because I ended earlier, then until j covers nums2, we would store its element into nums again and again until j covers nums2 completely. Now after this, we have written the whole code. Let's just see again what each line of code does. This does the task of comparing that we did until one of them, I or j, covers their arrays completely, and some elements might be left uncovered in either I, or some elements might be left uncovered in either j's array. Some elements might be left uncovered in nums1, or some elements might be left uncovered in nums2. So to fill the uncovered elements in nums again, we have to run a loop and check for both I and j, that is both for nums1 and nums2, to cover up the uncovered elements by checking if I has reached its required index or not, that is it has crossed the array or not by reaching the full length of the array, or j has reached the full length of array or not. Now once we have done that, let's just check if our code is working or not. Now this is our code. Let's check one last time. Yeah, everything seems to be fine. Nums 1 I is nums k is nums I plus plus s nums k is nums to j plus plus so 1 length nums k dot nums 1 I nums to length nums k is equals to nums dot j. Yes, we didn't increment it here. One thing we missed here is that we might be in hurry, that we didn't increment I and k here. Whenever we store elements of nums 1 I in nums k, we should increment the I, because we have to store the next uncovered element too, and we should increment k also, as we have to store the next element in nums, not into the same index. Now we have to do the same for j. Now once we have done that, now we have merged both the arrays into nums. Now after merging both the array into nums, to find the median, we have to check if nums.length mod 2 is not equals to 0. That means it is odd. So we would simply return nums.length by 2. That is the middle element. We would simply return it. Else we would return double. Why double? Because we don't want an integer as the average of both the element. Rather, we want it as fraction or decimal. So we would just sum the both the middle elements, that is nums mid minus 1 and nums nums dot length by 2 and nums dot length by 2 minus 1. That should be our sum, and we would divide it by 2, and we are taking the sum as double so that we get the average when we divide by 2 as a decimal value, not as an integer value. Now once we have done that, we should save our program and just copy it. Now let's see if our code is right now. It seems to be fine. Yeah, it seems to be fine to me. Let's just run it. Yeah, we have just missed one bracket, and we might have put an extra bracket. Let's see what bracket we missed. This is closed. Yeah, this was not closed. We didn't close this. This remained unclosed. Yeah, we are getting the right answer. For 1, 3 and 2, for the nums 1 as 1, 3 and nums 2 as 2, we are getting the right answer, that is 2.000. Now let's check another test case, that is 1, 2, 3, 4, or 1, 3, 2, 4. We can check this also. Yeah, we are getting the right answer. Let's check according to the question 2, 1, 2 and 3, 4. Yeah, we are still getting the right answer. Now this is a code in small. Let's just I will zoom it for you so that you can see more clearly. This is the code. As you can see, you saw here the whole code. I will just scroll it so that you can notice it even more clearly. This is the code that I have written. Now let's just try to first submit it. If my answer would be wrong, then yeah, it got submitted. and it is faster than 81% of the submissions for this program, for this question. So our program is pretty fast when we see it. So that's how we should do this, and we are getting a right answer. So that was the solution. If you found the video helpful in any way, please make sure to like and comment on my video and subscribe to my channel, as it provides support and motivation to somewhat upload these kind of videos. And if you like the video very much, share among your friends too, so that they can see it too and benefit from it. Till then, goodbye.